Welcome to the presentation for our paper WebAssembly modules as lightweight containers for liquid IoT applications. I am Niko Mäkitalo and I come from the University of Helsinki. Here you can see the overview of the presentation. We start with the background about what exactly is liquid software. Then we continue to our vision for liquid software for IoT. Then I will give you some information about the status of the used technologies. After this comes the architecture of our proof of concept implementation. Unfortunately, in this presentation I cannot show you a demo, but I will provide you a link that you can watch the demo afterwards. As almost as a final thing, I will map some future research directions for liquid software for IoT and for our vision. Finally comes the conclusions. So, what is liquid software? Well, liquid software has been studied for years in different contexts. For instance, it has been studied in a web context, mobile devices context, and lately, of course, also in IoT context. As the Liquid Software Manifesto describes, the most fundamental idea of liquid software is, of course, that it can travel between different devices. And the aim of liquid software is to make this as smooth and as hassle-free and fluid as possible. In essence, this means that all users' data shall be synchronized between different devices. And to make the user experience as seamless as possible, this means that the full state of each application shall roam between the different devices. And naturally, this should work between heterogeneous devices, not just devices coming from one vendor. Finally, of course, the user must be in full control how his or her data will travel between the different devices. So I think this sounds like a pretty nice idea for also the user experience for IoT devices. And this is actually what brings us to the vision for our paper. So of course, liquid software could be implemented in various ways. Unfortunately, however, the current technologies, like for instance container technology, can be pretty heavy for very constrained devices that IoT devices typically are. I'm not going to go into details regarding the container technology and how heavy it is, but I'm sure that you can find references and think about this by yourself also. So in this vision of ours, Web of Things standards and WebAssembly technology play a key role. We are presently using these two for realizing lightweight containers for IoT that will enable the liquid computing paradigm. So in this figure, you can think about how this all should then work. So there is a developer who will implement some modules with source languages like C++ or Rust, for instance. Then, while the source language modules are compiled, also a metadata file gets generated. And this metadata file actually describes the requirements for the module, so that other modules then can leverage these new modules. And in our vision, the idea is that these modules could be then deployed to all kind of different smart network nodes, like smart routers, of course, to cloud services and other kind of edge servers. And then the user simply downloads and installs an application. And for this application, the user gives certain permissions. So, what kind of data the application is allowed to access, for instance, and also in which context. And then, when the user interacts with the the application or doesn't actually necessarily interact with the actual application, but like does something in the environment, interacts with the devices, or like sensors will sense something that the user does, then new modules gets automatically loaded from these smart network nodes. So now of course the challenge is that there is currently no such technology that will enable this kind of like liquid computing. And for this reason we have started implementing this kind of like liquid containers that are lightweight and which could run on different, also on like constrained devices. And in a very key role there is WebAssembly technology. So WebAssembly is actually initially designed to run within a like web browser, but nowadays it has also started to like come out of the browsers, and different WebAssembly runtimes has been implemented. These runtimes also have their flaws, and many of those don't actually support loading dynamically new modules like during the runtime. And for this purpose we have implemented like a dynamic linking and loading solution for WebAssembly. It is based on Wasam-time virtual machine, and it offers different APIs for loading shared libraries and then linking these during the runtime. It also allows kind of like breaking the sandboxed environment, and by this I mean accessing different hardware features. This is of course necessary, especially like when working with IoT devices. At the moment our implementation supports Android devices and also Raspberry Pi and Linux environment. In future it is of course also possible to support also more constrained devices than for instance like Raspberry Pi is. Here you can see a link to our demonstrator video, so you can see actually the runtime implementation in action. So for now our implementation has mostly been focusing on the WebAssembly and dynamic module loading part. Here you can see some future directions for our research. So very fundamental for liquid computing is the state synchronization, and we need to think about the like previous research regarding liquid software and take these results into account and try to merge these into our runtime. It is also necessary to like dynamically orchestrate the roaming of the applications between the devices, and this is also a very important next step for our implementation. Also currently, as I mentioned, WASI and WebAssembly support accessing certain hardware. However, it is challenging to support all the different devices. As you can know, there can be a number of different kind of like IoT devices, for instance wearable devices or healthcare devices and all kind of different devices. So the support for accessing the hardware must be really something very comprehensive in order to actually provide the liquid user experience. Then we also of course need some kind of like very fine-grained security model that will allow the user to define in which context and which applications can access which data. One final future research direction is the benchmarking. So measuring the WebAssembly applications and liquid software applications is very challenging. But this is something very important because the idea of the liquid software is to provide seamless user experience. So we need to somehow be able to measure how the applications perform so that we can actually improve the user experience. Here you can see some conclusions for the presentation. So in our paper, most of the focus was on WebAssembly technology and using that for building liquid containers that enable the very basic behavior for the liquid applications. Already our runtime implementation could be used for implementing an ecosystem of different modules that can be dynamically loaded to Android, Raspberry Pi and Linux environments. However, there is still plenty of research to do to provide real liquid user experience. Thank you for watching this presentation, and please feel free to contact me if you have any questions.